Almost every networked application you have ever built relies on one foundational idea. Some participants ask for things and others provide them. In this video, we will name that split precisely, understand why it exists, and trace how a request moves through a client-server system from the moment a user acts to the moment data comes back. Imagine 10 developers all keeping their own copy of a shared database on their laptops. The moment one person updates a record, every other copy is out of date. Coordination becomes a full-time job. You also cannot enforce who is allowed to see what, because there is no central point to check. This is the pressure the client-server model was designed to relieve, the chaos of fully decentralized peer-equal machines sharing the same data. Think about a restaurant. You, the diner, do not walk into the kitchen and cook your own meal. You place a request, an order, and the kitchen, which controls all the ingredients and equipment, prepares the result and sends it back to you. The kitchen is the single authority. Every diner gets the same menu, the same rules, and a consistent experience. That is exactly the relationship between a client and a server. Here is the structure in its simplest form. Many clients, browsers, mobile apps, desktop applications all send requests to a single server. The server is the gatekeeper. It receives every request, applies rules, and coordinates access to a shared data store. Clients never talk to each other and never touch the database directly. This centralization is the whole point. It gives the server authority over consistency, security, and shared state. Follow a single request through the system. The client, say a browser, sends a message asking for a user profile. That message travels across the network to the server, which first checks whether the caller is allowed to make this request. The server then reads from the data store, assembles the answer, and sends it back. The client only ever sees the finished response. The key consequence is a clean separation of concerns. The client handles presentation, the server handles logic and data access, and neither needs to know the internal details of the other. The client-server model trades decentralization for control. Centralizing the server makes data consistent and access easy to govern, but it means the server is now a bottleneck and a single point of failure. Every client depends on a working network path to that server, and as client count grows, the server must grow with it. These are not reasons to avoid the model. They are costs you need to plan for explicitly when you adopt it. When you adopt the client-server model, the most important discipline is keeping the boundary clean. Clients present and interact, servers decide and store. If business logic leaks into the client, you lose the consistency guarantees the model was built to provide. Define the server's interface, its API, as an explicit contract so clients and servers can evolve independently. And because the server's now load-bearing for the whole system, redundancy is not optional. Plan for it before you need it. The client-server model is the architectural foundation beneath nearly every network system you will ever work on. Its core insight is simple. Separate the role of asking from the role of answering, and centralize the authority that coordinates shared data. That centralization is a strength. It gives you consistency and control, but it also makes the server a critical dependency. Understanding this model deeply means you can reason clearly about every layered, tiered, or web-based architecture built on top of it.